Well, good news, everyone. You don't have to learn anything new today. So, chapter 4.6 is all about just taking everything you already know and put it into one problem. So let's take a look at page 216. So we talked about a rigid motion or a congruent transformation. So there's three of those. What are they? You got this. Come on. Translation? Reflection? Okay, so those are rigid motions. The pre-image and the image are going to be congruent, right? And then we learned about one that is not a rigid motion, which is dilation. Okay, so the dilation is what we call a similar transformation. So the pre-image and the image are similar. They have the same shape, but they don't have the same size. So what we're going to do today on 4.6 is just do combinations. So we're going to do a translation and then a dilation, or we're going to do a rotation and then a dilation, or something like that. They're pretty straightforward. Let's look at example 1 for a minute. Remember what color is always the pre-image? Yeah, the blue one. So how are we going to go from the blue one to the red? Is that just what type of transformation is that? Yeah, that's a translation. Good. Okay, and then how do we go from the red one to the green one? It is a dilation. So I think as we look at example 1, let's just talk about the mapping function. So xy is mapped onto. Okay, so how are we going from A to A prime, guys? Okay, so are you saying plus or minus? Are we going to the right or to the left? Okay, so that's plus, right? Plus what? 5, and then y plus 1. Okay, so there's the mapping function to get us from the blue to the red. So there's our translation. And then we have to think about what is the scale factor, right, to do the dilation. And there's a couple ways to do the scale factor. One of them, since we already have it graphed, everyone just look at A prime and A double prime. How do you get from the origin to A prime? Think about the slope. Up how many? Up 2 over 1, right? How do you get from the origin to A double prime? Okay, up 4 over 2. So any guesses on the scale factor? Okay, is it 2 or is it a half? It's got to be 2, because the pre-image is smaller, isn't it? Okay, it's growing, so we know that the scale factor has to be greater than 1. So that's one way that we can look at it. The other way we can look at it is we can literally look at the points themselves. So here's point A prime, which is 1, 2, and then the green A double prime is 2, 4. And remember, whenever we use the scale factor, whenever we go from A to A double prime, what we do is we take x times k and we take y times k. And that's how we do it, right? That's how we do the dilation. We just multiply each of the ordered pair coordinates by the scale factor. So you can see what's going on. It's pretty obvious. I don't think you're going to have any problem with that one. Here's the fun one. Let's look over at example 2. This one, they give us the blue image, so the pre-image. They give us the green one, which is the second image, right? And they don't give us the one in between. They don't give us the red one. So we've got to figure out where that red one is and what's going on. Okay? Now this one's pretty easy because the answer picture is right underneath it, right? So you guys are all like, well, that's obvious. We can see the answer to this one. But notice how it's a reflection and then a dilation. And, ooh, a reflection across which line? The y? And the dilation, is it greater than 1 or less than 1? Less than 1? What is it? What does k equal for the scale factor here? Yeah, 1/3. Can you notice that the points, if you multiply them by 1/3, you go from the red point to the corresponding green point, don't you? Okay, you got it. Now let's do a hard one. Let's do one where we've got to do it ourselves. So down at the bottom of the page, we've got this figure, G F D, which is -2, 3, and E, which is 1, 4. So we have this figure. This is our pre-image. It's like the pre-image, right? So we got two of them going on, and then we got the green one, which is V is at negative at half right here. 0, -1/2. S is over here at 1. Is it 1.5? There's S, and then T is at -1/2, -2, and U is at -2, 0. So we can see this is a similar transformation. There's a couple things going on. Do you guys see a translation going on here? Any kind of a slide action? Okay, how about reflection? I see some yeses and nos on reflection. Something's got to happen because you can see they're not orientated the same way, are they? But is it a reflection or could it be a rotation? A rotation? So as we look at that, we rotate it around. What do you think? Is that working? But not only does it have to rotate around, what has to happen? How far is it rotating? Okay, so we've got a dilation and a rotation, right? 180-degree rotation. So what does that tell you about the scale factor? The scale factor could be a negative number, right? Okay, so our scale factor is probably a negative number and greater than 1, less than 1. Less than 1? Okay. So if we look at the corresponding points, this is at 0, 1. This one's at 0, 1/2. What do you got to multiply 1 by to get 1/2? Okay, so -1/2. Does that work for everything? So like here we're at 4, corresponding one's -2. What's 4 times -1/2? -2. Okay. Does it work for all of them then? Okay. So even though this is a composition, we're doing two things. We're doing a rotation and a dilation. We can explain it with just one simple thing. Just make the scale factor -1/2, and it'll do both those things, right? Right? Oh, good job. Okay. All right. On the next page, it just talks about squares being similar. Are all squares similar? How do you know? Yeah.
Because all of their sides are congruent no matter what, so
So all four sides of the square of every square are congruent, right? Let me. If I start with any square, so its side length is n, whatever that is. Can I dilate it by some scale factor and get any other square?
yeah.
Sure. Okay, so if I have a small one, this side might be 1/2 n. So they're similar, right? If I have a bigger square, could the scale factor be 8 or something like that? We're going to multiply every side by 8. We're still going to work out, aren't we? So every single square is similar. What about every rectangle? What about every triangle? So some rectangles similar? Some triangles similar? Okay. This is actually pretty easy and kind of fun. I made a bunch of graph paper for you, so here we go. Chapter 4.6. I think you got time to get this done in class today, and no homework and no worries. Midterm Friday, eh? Let's make sure you got everything caught up if you haven't already.